Today we're going to go over something called between statements, which come from the and compound inequalities that we looked at yesterday. So if we have an and compound inequality to start off with, so that's two inequalities, connected by conjunction and, right? And those two inequalities make a connected graph. Right, all the numbers bigger than 0 and all the numbers less than 5. If they make a connected graph, because some do but some don't, right, that means we can rewrite this as a between statement. And there's a few steps here to do that. Right, because we call it a between statement because all of the answers are between two numbers, between 0 and 5. So here's what we do. We take the smaller of the two numbers. Usually the one on the graph, it's going to be the one on the left. So here it's going to be the greater than or equal to 0, right? And we actually flip it around. We take the second one, keep it as the same, and kind of like a conjunction, like the word don't, do not, comes from two words. You combine together to make one word. We can combine these two together just like this. And it has two inequalities in it. And the way you actually say this is x is between 0 and 5. As opposed to saying 0 is less than x is less than 5, we actually say this, between. All the numbers between 0 and 5, or x is between 0 and 5. Okay? So a few things about this is that we have a number on either side. The number on the left, just like we picked earlier up here, has to be the smaller of the two, right? And we have to have less than or less than equal to, but they always point to the left in either case, in every case. They must have these two criteria to be a complete answer. So let's just practice converting a few of these and statements, if they are convertible, into between statements, because not every problem can be converted to between. And again, the way you know that is if you graph it, the graph must be a connected graph. So if we're looking at all the numbers bigger than -3 and less than 5, and you go ahead and graph that, you find out that, yeah, that is a connected graph, which means we can rewrite it as a between statement. So find the smaller, right, which in this case is x is greater than -3. -3 is smaller than 5. We're going to flip that one around, and that will be on the left, and we'll just simply put in the less than 5 on the right side of the between statement, and we'll get something like this. So small number on the left, notice how both inequalities are going less than. And this one stays the same, but this one is the one we flipped around. Okay. On number 2, again, ask yourself, is this a connected graph? If we want numbers that are less than or equal to 10, and they're also greater than or equal to 4. So basically, what numbers are smaller than 10, but they're also bigger than 4? That indeed is a connected graph. They're just saying, oh, that's all the numbers between 4 and 10. Notice how here, though, the smaller number is written second over here. So you don't want to automatically just, whatever we have written here first will be the first part of your answer. We're always looking for the smaller number. Over here, -3 is smaller. That's why it's right here. If you look at the graph, you notice 4 is on the left. That means this is the part we flip around, and that'll give us our between statement. Notice how this part, x is less than or equal to 10, is basically the same thing, just written right here. Okay. Lastly, we have all the numbers bigger than 8, it's greater than 8, or smaller, less than 7. So if you think about it, is that something that will be a connected graph? So greater than 8 would be this way, and less than 7 would be this way. So this is not a connected graph. Therefore, there's no between statement. It has to be a connected and statement. And this answer for this would actually be no solution because there's no overlap of the graph. Therefore, no between statement. So that's a few converting from the and format of the compound inequality into the between format. They're both considered, both ways of writing it are correct. They're just different formats. A few things about how the answer should be at the end of a problem. So had this up here earlier that the smaller number must be on the left, and we always have less than or less than or equal to. So if you get to a problem like this, and you get an answer like this, you want to be able to look at this critically and see that, well, in this particular answer, yeah, the inequalities are less than, so that's good. But you know what? The small number is on the right side, not the left. And a small detail like that will make this a no solution. And same thing over here. We do have the small number on the left, so that's good. But the inequalities are going the wrong direction. See up here? They must be less than or less than equal to. So something's wrong with both of these for the same reason, no solution. One more down here, you can see both the inequalities are both going greater than instead of less than, and the smaller numbers on the wrong side. Now this, on the other hand, we can actually work with. Because they're both offset, we can actually flip the whole inequality around. You can kind of see how it flips it around. Just like we rewrite a single inequality, like x is greater than 2 to 2 is less than x, we can rewrite this. So if you're able to basically hold a mirror up to this, and it turns it into the right format, then you're okay. And that is the answer. So the only time where we can really do that is if they're both greater than and the number's on the other side, then we can flip it around to be the right format. Otherwise, if there's just one or the other wrong, then we have no solutions. All right, and this will come in handy. You have to do this at the end of every in-between statement that we solve, which I'll show you one next. So like this. You can notice that this is a little different. We have 3 parts. You're used to having, the left side and the right side, and you add to both sides, subtract to both sides. Well, here we have 3 parts. We have a left, a middle, and a right-hand side. But we're going to follow the algebra like we always do. So we always start with a variable, and we look at this part only, and we say, well, it's a plus 4, so that must mean I need to subtract 4 on both sides. But in this case, instead of both sides, we have 3 parts, all 3 parts. But the rest is normal, so just trust your instincts. You already know how to simplify vertically. So we have the -5 minus 4, we get -9. We have the 4 minus 4 is 0, cancels out, and 7 minus 4, which is 3. So that simplifies to this. And just like before, if we had 3 times a number, we could simplify that by dividing by 3. So all 3 parts. Simplify, divide, -9 divided by 3 is -3. And 3 divided by 3 is 1. Now the 3 divided by 3 here cancels out. It's technically a 1, but we don't write 1x, we just write x. So here we need to write 1, but for this one we don't. Just leave the x by itself. And again, ask yourself, is this in the proper format? So we have the smaller number on the left, so that's good. And we have both of them are less than or equal to. So that would be okay as far as an answer. And then if we graph it, we're expecting, since it's a between statement, the answer is, like we literally read this, all the numbers between -3 and +1. Just watch that this is an equal to, so we do have a closed circle while this one does not have the line, so it's open. And there you go. Last example, we have some more solving. Again, you're focusing in on here in the middle and do the adding and subtracting first. This is a +6, so we must subtract 6, left, middle, and right. And this is a -x or a -1, which means I need to divide everywhere by negative. Now recall that if you divide by a negative here, gotta switch the sign. And now we gotta switch both signs. And then look at this closely and ask, is it in the proper format? And quickly you'll see, no, we have the bigger of the 2 numbers, 10 and -2, the bigger is on the left instead of the smaller, and they're going the wrong direction. But if you think back to what we saw earlier, if they're both incorrect, so we have them both incorrect right here, where the negative or the smaller numbers on the right and the inequality signs are incorrect, we can flip it around, right, and still have a correct answer that does have a graph. Otherwise, we'd say, well, no solution. Okay, so hopefully that helps. Take good copious notes here, because you can see there's a lot of little details that if you're not careful will trip you up. So definitely have your notes out while you're doing your assignment, and that will probably be your first go-to if you ever get stuck on something. All right, let's get started.